Welcome back to the deep dive. So we've got a bit of a weird one today. I have 2 stacks of notes here on my desk.
Yeah.
And honestly, if I didn't know better, I'd say you grabbed files from 2 completely different courses by mistake.
It certainly looks that way at first glance, doesn't it?
Right. I mean, in this left stack, I'm looking at very rigid, very logistical computer science stuff. You know, teams, roles, a really weird numerical rating system for coding skills. It feels like a project management seminar. But then over here in the right stack, I've got this deep psychological dive into the human brain. We're talking about things like adult learning, theory of margin, schema, and self-handicapping.
It's a jarring mix, for sure.
It is. So before we get into the details, maybe you can help me bridge this gap. Why are we analyzing psychological theories right alongside a list of software engineering homework?
Well, it comes down to one fundamental realization that this course material, specifically these Class 2 notes and the learning concepts, is really trying to drive home. You cannot build good software, and you certainly can't build a functioning software team if you don't understand the hardware running the whole operation.
And by hardware, you don't mean the servers.
No, not at all. I mean the human brain. The source material actually calls these class infinity concepts.
Class infinity.
Yeah, the idea is that, the coding languages will change, the tools are going to change, but the way your brain processes information, the way it gets overwhelmed, how you work with other people, that doesn't change. If you ignore the psychology, the project is doomed.
So the argument is that we need to sort of hack our own brains before we can even start to hack the code.
In a nutshell, yes. We have to optimize the learner before we can optimize the software.
Okay, I'm game. But looking at these notes, there's some heavy stuff here. Where do we even begin?
I think we have to start with the engine itself. Motivation, but probably not the kind of motivation you're used to hearing about in school.
Usually school motivation is just get an A so you don't get grounded, or, get a degree so you can get a job.
Exactly, and the notes identify that as extrinsic motivation, rewards and punishments. And here's the real kicker. The research in these notes claims that extrinsic motivation is actually the least effective way to learn.
Which is pretty ironic considering the entire education system is built on it.
It is, but this is where the concept of andragogy comes in.
Andragogy. I honestly assumed that was a typo for pedagogy.
It's a specific term for adult learning. You see, pedagogy is for kids. You learn what the teacher tells you because they told you to. Andragogy, and they cite researchers like Knowles and Swanson, it says that adults are different. Adults are problem-centered.
Meaning?
Meaning an adult brain doesn't really absorb information just because it's on a PowerPoint slide. It absorbs information because it needs to solve a specific problem, like right now.
So if you're trying to learn a database language just to pass a quiz on Friday...
That's weak motivation. Your brain is going to dump that information the second the quiz is over.
But if I'm trying to learn it because my team's project is completely broken and I need to fix the back end...
That is intrinsic motivation. You have a need to know. The learning is relevant. The notes argue that to succeed in this course, you have to shift your mindset from, I need to pass, to, I need to solve this problem.
That sounds great in theory, but let's be real. Students are busy. They have jobs, families, other classes. It's hard to stay intrinsically motivated when you're just trying to keep your head above water.
You absolutely hit the nail on the head. And that brings us to, I think, my favorite concept in this entire stack of papers, the theory of margin.
I saw this. It looked like some kind of math equation. Margin equals 1 minus load over power.
Margin equal 1, load power. It's a formula by a guy named McCluskey. And frankly, I think it should be tattooed on every student's arm.
Okay, let's break it down. Because I was never great at algebra.
It's simpler than it looks. Load is just the energy drain. It's all the external demands. Your job, your commute, your financial stress, the argument you had with your partner, and yes, the difficulty of this class. That's the weight on your shoulders.
And power.
Power is all the resources you have to cope with that load. Your physical health, your finances, your support system, your existing coding skills, your ability to focus.
So if my load is huge, let's say I'm working 2 jobs and I'm getting sick, and my power is low.
Then that fraction, load divided by power, it becomes a number that's bigger than 1. And 1 minus a number bigger than 1 is?
Negative.
Negative margin. You are in the red. And the notes make a really, really critical point here. When you have 0 or negative margin, Your brain just switches modes. You stop engaging in growth and you switch entirely to self-maintenance.
Survival mode.
Exactly. You physically cannot learn complex new topics like software architecture when you are in survival mode. Your brain shuts the door to save energy.
That is actually kind of terrifying. It suggests that if you're failing this class, it might not be because you're not smart enough. It might just be that you haven't audited your own life to get your margin positive.
Precisely. The class infinity lesson here is that before you even look at the homework, you need to check your margin. Can you reduce the load? Maybe drop a commitment? Can you increase power? Get more sleep? Ask for help. If you don't do that, the study session is basically useless.
But there's another blocker in the notes, isn't there? I mean, even if I have the time and the energy, there's this section on self-handicapping. He talks about the imposter.
Ah, yes, the psychological paradox.
It describes a student who wants to succeed, but then deliberately chooses not to study for a critical test. That makes no rational sense. Why would I sabotage myself?
It makes perfect sense if you understand something called contingent self-worth.
Okay, break that down for me.
Let's say your entire identity is built around being the smart kid. You've always breezed through school. But now you hit a class that's actually hard.
Okay.
If you study your absolute hardest, put in 100% effort, and then you fail the exam, what does that say about you?
It says I'm not the smart kid anymore. It says my best wasn't good enough.
And that is devastating to the ego. So what does the brain do to protect itself? It chooses not to study. Because if you don't study and you fail, what's the reason?
Oh, I failed because I didn't study.
Bingo. You have a built-in excuse. You get to keep your identity as the smart kid who just didn't try, rather than risking the reality that you might not know something. It preserves your self-worth, but it completely destroys your ability to learn.
That's twisted.
It's human nature, and it's a symptom of what the notes call a fixed mindset.
This is the Dweck research, right? Carol Dweck.
Yes. The notes list 3 rules for the fixed mindset. Rule 1, look talented at all costs. Rule 2, don't work too hard because, effort implies you lack talent. And rule 3, conceal deficiencies. Never let anyone see you make a mistake.
Which is basically the worst possible strategy for learning software engineering.
It is fatal. Coding is literally 90% making mistakes and fixing them. If you're hiding your errors, you aren't debugging. The growth mindset just flips all those rules. It says, learn at all costs. Effort is the key to mastery. And, most importantly, embrace your mistakes. Confront the deficiencies so you can actually fix them.
There's a quick mention of stereotype threat in here, too. Does that play into the same kind of anxiety?
It adds another layer on top. If you belong to a group that is negatively stereotyped when it comes to, say, intelligence or tech skills, that just creates this background anxiety, this feeling of, if I fail, I'm confirming the stereotype.
And that anxiety is a load on your margin.
Right. It eats up working memory that you should be using for coding.
Okay, so we've got the emotional baggage unpacked. We know we need margin. We know we need to stop protecting our ego. But let's talk about the actual mechanics. The notes have a section on cognitive information processing.
The front door?
Right. It says attention is the front door. If you don't pay attention, the information never even gets in. But then it goes in this whole rant against multitasking.
Is it really that big of a deal? I mean, I feel like I can listen to a lecture and check my email pretty effectively.
You feel like you can, but the data says you really can't. The notes cite a 2020 study, Mercimek et al., I believe. It basically debunks the whole myth that digital natives are better at multitasking. They just aren't.
So what's actually happening in my brain when I switch tabs?
You're clogging the front door. Every time you switch contexts, you lose data. The notes suggest using a little mnemonic to keep your working memory engaged. A-E-I-O-U.
I saw that. Apply, elaborate, interpret, organize, understand. It sounds a little bit like a poster you'd see in an elementary school classroom.
It's catchy, sure, but the science behind it is deep, especially the O's organize. This leads us to what I think is the most fascinating study in the entire deck, the chess experiment.
Oh, this one was cool. Simon and Chase, 1973. So they take grandmaster chess players and total novices. They show them a chessboard for just a few seconds and ask them to recall where all the pieces were.
And obviously, the grandmasters crushed it.
When the pieces were in a logical, real game position, yes. The experts recalled almost everything. The novices, they recalled maybe 4 pieces.
Proving that chess masters just have superior memories.
That's what they thought. But then they did a second round. This time, they placed the pieces on the board completely at random. Impossible positions, pawns where they shouldn't be, just chaos.
Yeah.
The experts just fell apart. Their recall was no better than the novices.
Wait, really? So their memory wasn't actually better?
No, their schema was better.
Okay, define schema.
Think of schema as a filing cabinet in your brain. A novice looks at a chessboard and sees 32 individual pieces. That's 32 separate files to open and memorize. It's
Wow.
way too many for your working memory. An expert looks at the board and sees the Sicilian defense. They have one single file for that entire pattern. They aren't memorizing pieces. They're recognizing a structure they've already built.
That is a massive distinction.
It's the whole concept of constructivism. You build new knowledge on top of old structures. When the board was random, the experts had no structure to hang the info on. Their schema just failed them.
So if I'm sitting in this coding class and the lecture sounds like complete gibberish, like random noise, it's not because my brain is broken. It's just that I don't have the file folder for that topic yet.
Exactly, you lack the encoding. And the only way to build that folder is through that slow, focused AEIOU process. You cannot multitask your way into building a schema.
All right, this is the perfect pivot point. We've talked about margin, motivation, schema. Now I want to bring in that other stack of papers, the logistics, because usually logistics are boring. But looking at these Class 2 notes, it feels like they designed the team specifically to solve all these psychological problems we've been talking about.
You are absolutely reading that right. This is not just find a partner. This is engineered.
So the class is dividing into 4 teams. And each team needs to cover specific roles: front end, logic, gamification, and back end.
But look at how they form the teams. They don't just ask, hey, who knows Java? They have this very specific rating card system.
The 0, 1, 3, 9 scale.
Right. And this is critical. It's not linear. You don't get to rate yourself a 5 or a 7. You have to make a hard choice. But the real genius is what you're rating. You rate your ability, sure, but you also rate your desire.
I noticed that. The example given is a student, John Doe, who rates himself a 9 in ability for a certain role, but a 1 in desire.
Now, think about that in terms of the theory of margin we just discussed. If John is great at Java high ability,
Right.
but he absolutely hates doing it, low desire, and you force him to be the Java lead, what happens to his margin?
It tanks. His load goes through the roof because he hates the work.
Exactly. He burns out. He goes into survival mode. By asking for the desire rating, the instructors are trying to maximize the power side of the equation. They want people doing work that gives them energy, not work that drains it.
It's a margin management tool disguised as a sign-up sheet.
That is a perfect way to put it.
And the skills they are asking for aren't just coding. They're listing leadership, attention to detail, requirements documentation.
Because a team isn't just 4 coders typing. A team is a social structure.
Oh.
If you have 4 people who all want to do logic and no one who has the attention to detail to check for bugs, your project fails. If no one has a leadership desire to organize the meetings, you fail.
Speaking of failing teams, we have to talk about the required reading. The notes mention the mythical man month, specifically chapters 2 and 14.
A classic. Fred Brooks.
Why are they reading a management book from the 70s?
Because of Brooks' Law. The book is famous for one statement. Adding manpower to a late software project makes it later.
Which sounds completely counterintuitive. I mean, if we are behind, shouldn't we hire more people?
You think so. But Brooks explains the math of communication. If you have 2 people, you have 1 connection between them. If you have 3 people, you have 3 connections. If you have 4,
The number of connections just explodes.
it's N-N-1-2. The communication overhead grows exponentially. So if your team isn't careful, if you don't have that schema for how to work together, adding more voices just adds more noise. It increases the load without increasing the power.
So reading this book is basically a warning label for the teams they're about to form.
It's a warning. More people doesn't mean less work. It means more communication.
Okay, we are coming up on time, and I want to make sure no one misses the deadlines here, because the notes are very specific. And based on everything we've learned, these aren't just dates on a calendar, they are tests.
They are filters.
First up, Friday, January 23rd, before 8:00 a.m. You have to verify your Linux login.
This is the attention test, the front door. If you miss this, you are basically telling the instructors your front door is closed.
Then Sunday, January 25th, the journal entry. And they cite a 2-1 rule. 2 paragraphs minimum, 1 quiz question included.
That's the elaborate part of AEIOU. Don't just copy and paste. You have to construct the knowledge.
And finally, Monday, January 26th. This is the big one. You need to turn in that rating card so that teams can be formed. And you need to have read the Mythical Man Month.
And please, for the sake of your future team, be honest on that rating card. Don't rate yourself a 9 in desire just because you think it looks good. That's that old fixed mindset trying to look talented. Be honest about what you actually want to do.
So here's the game plan for you, the listener. This weekend, before you even tackle the journal, I want you to calculate your margin. Literally, sit down, look at your load, look at your power. If you're in the red, fix that first.
Absolutely. Go for a walk, get some sleep, do whatever you need to do to increase your power.
And when you open those class notes and you feel that panic, that feeling that is all just random chaos,
Remember the chessboard. It's not chaos. You just haven't built the schema for it yet.
keep building the files. We'll see you in the next deep dive.